My name is Dr. Peter Moore. I am adjunct faculty in the Department of Natural Resource Ecology and Management at Iowa State University. And I have a project funded by the Iowa Nutrient Research Center called Influence of Bank Stabilization on Sediment and Phosphorus Storage on Floodplains. So one of the things that we've been interested in for several years now is the role of stream bank erosion in supplying loads of sediment and particularly phosphorus to surface waters. So we have banks like this, a cut bank this is on Iowa Creek, just outside of the campus of Iowa State. And this is a typical cut bank where the creek comes around a bend, and on the outside bend it tends to erode quite a bit of the sediment away. And particularly the fine sediment that comes in from that cut bank erosion carries with it frequently some phosphorus. In some studies we've found that that is a significant source, and statewide maybe as much as a third of the phosphorus entering streams is coming from stream bank erosion. But that's only part of the story, because some of that sediment and the phosphorus attached to it also gets deposited by the river. And as a freely migrating or meandering river moves across its floodplain, it not only erodes one bank, but it deposits sediment and the phosphorus that it carries on the opposite bank, and we call that the point bar side. It also deposits it during floods on the floodplain itself. We're interested in particular in the possibility that one might be able to use, or we might be able to use, stream bank stabilization as a practice to reduce inputs of sediment and phosphorus into surface waters. At the surface, or superficially, that seems to be a pretty effective practice, but it also may have impacts on the natural processes of redeposition of sediment. So we're interested in how bank stabilization structures, like the riprap that you can see in the distance on the bank behind me, how that influences the shape of the channel and the opportunity that the creek has for redepositing sediment that carries phosphorus with it. We're going to use a couple of methods to approach this problem. One of them is entirely in the office at the desk, and that's using our Iowa statewide LIDAR imagery. And we're going to use the LIDAR data to compare point clouds from 2010 to 2020. We'll be doing this work primarily in southwestern Iowa on the Nishnabotna River, the West Nishnabotna River. And we'll be comparing point clouds from 2010 to 2020, and the LIDAR gives us an ability to have an elevation of the ground at each point where there's a return. And so we can see the elevation change over those 10 years, and in that way we can quantify how much sediment accumulation has happened on point bars and on floodplains like that.